on the circle theorem. Alright, so today we are going to talk about a particular theorem on circle theorem, and the theorem states that the sum of the opposite interior angles of a cyclic quadrilateral is 180 degrees. I repeat myself. The theorem states that the sum of the opposite interior angles of a cyclic quadrilateral is 180 degrees. Assume this is a diagram given, alright, and I can call this to be my A, alright, I can call this to be my B, I can call this to be my C and my D. Okay, I can now construct a line from B to C, construct a line from D to C. Alright. Alright, so this is a cyclic quadrilateral, right? Now I repeat myself that the theorem states that the sum of the opposite interior angles of a cyclic quadrilateral is 180 degrees. That means we have to prove that this angle is opposite to this angle, that is 180 degrees. Alright, let's prove. Now we have to prove that angle BAD, alright, plus angle BCD, alright, is equal to 180 degrees, because that is what the theorem states. The theorem states that the sum of the opposite interior angles of a cyclic quadrilateral is 180 degrees. So to prove that this angle BAC plus angle BCD is equal to 180 degrees, and this is BAD, alright, that plus, okay, this angle plus this angle is 180 degrees. That is what to show and to prove. Alright, so let's do a construction. I have already constructed. This is my center, which is 0. Alright, so let's prove by lettering figure above. So can we say that angle BAD is equal to I can call this, let me call this my x1. Alright, let me call this angle x1, let me call this angle x2. Alright, now we have to prove that angle BAD is 1/2 of x1. Reason is angle at the center. Angle at the center is twice angle at the circumference. Please, this is circumference because of space. This is circumference. Alright, so that is the reason. Now we know that angle at the center is twice the angle at the circumference of the circle. Remember that theorem that said that angle at the center is twice the angle at the circumference. So if the angle BAD is 1/2 of x1, that is this angle, that means that is the angle at the center. That is angle at the center is twice the angle at the circumference. Alright, so we can repeat the same with this angle. We can say angle BCD, okay, is equal to 1/2. That angle will be x2. You can say that x2. Now what is the reason? It's the same reason. You can write the same reason, right? Same reason. Alright, now angle at the center is twice the angle at the circumference of the circle. If the angle at the center is twice the angle at the circumference, that means angle at the circumference is half of the angle at the center. I'm sure you are getting me. If angle at the center is twice the angle at the circumference. That means angle at the circumference is half the angle at the center. Alright. And do you know that if this exists, now we can say that, but do you know that but x1 plus x2 is equal to 100, is equal to 360 degrees, is equal to 360 degrees. I'll prove that. Now, but x1 plus x2 is equal to 360 degrees. Why? Now, do you know that this angle, angle BAD, right, is equal to 1/2 of 360, right? So angle BCD is also 1/2 of 360, and 1/2 of 360 is of 360, which is equals to 180, and this is equal to 180. So remember that this angle BAD is equal to x1, while angle BCD is equal to x2. So if this angle is opposite, if this angle is this angle, that means if I add the sum of this angle, that means, so therefore x1 plus x2 is equal to 2 times of this and this, which is this plus this, equal to 360. Alright, so we can prove that, therefore we can show that angle BAD, right, angle BAD plus angle BCD is equal to 1/2 of x1 plus 1/2 of x2 is equal to this and this are common, so you can say 1/2 of x1 plus x2. Alright, and if this exists, from here we can say that this is equal to 1/2 of 360, and 1/2 of 360 is equal to 180 degrees, and that is the proof we have to look for. We have to prove, and we have successfully proved that that angle BAD plus angle BCD is equal to 180 degrees. So remember, the theorem states that the sum of the opposite interior angles of a cyclic quadrilateral is 180 degrees, and we have proved that that theorem do exist, which is equal to 180 degrees. So I'm going to give you what to do on this, that is work example. Thank you and stay connected.